4 tells us to write an equation for the function f of x is equal to the absolute value of x reflected over the y-axis and horizontally compressed by a factor of 1/4. Okay, so here's our original f of x is equal to absolute value of x. So what we're supposed to do first is reflect it over the y-axis. So reflecting it over the y means that we have a horizontal reflection going on. Okay, so we have horizontal reflection, and we're also told that we're supposed to horizontally compress it by a factor of this guy here. Okay, and then we also have horizontal compression. Okay, which actually means that our b, the factor that we're going to have to multiply x by, is equal to the reciprocal of this guy. Okay, so that's going to be a 4. All right. Because remember, when we have horizontal transformations going on, things get a little bit weird, or like kind of like opposite, right, of vertical. So in this case, when our constant that we're multiplying by is greater than 1, then we actually have compression happening horizontally. Okay, so let's see what we're going to do with this. So horizontal reflection means we add in a negative sign in with our x. Okay, so that would just give us f of, well, not f anymore, but we're just going to have a negative in with our x. Okay. So that gives us the horizontal reflection, right? And we actually see because of the absolute value sign, it's going to do absolutely nothing. Actually, anyways, so then we also have this horizontal compression. So that means we have to add that factor of 4 inside with the x because it's horizontal, so it has to affect our input directly. Okay? So this would be the formula. This is the equation for our new function. And let me just graph it just to show you guys a visual. So, like I said, this negative sign doesn't do a whole lot of anything. Just because we have an absolute value graph. Okay, so here's our original absolute value. All right, so this is our normal absolute value of x, which is also equal to the absolute value of negative x, so we don't have to worry about that. And then what would the other one look like? So this would be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so if we had something like this, we would still have the base being, or the vertex being at 0, 0. But let's say you plug in a 1. And now we get 1, positive 4. So it shoots up already to positive 4. When you plug in a 2, we get, positive 8. Okay? So it's going to be a really, really, like, narrow V going on. I don't know why I put that point there. There we go, up here. Okay? So it'll look like a V like this, which actually looks like a more normal V. Anyways, so this is it. So this is equal to the absolute value of negative 4x, as is equal to positive, or the absolute value of positive 4x. Like I said, the negative sign doesn't make a difference because it's inside the absolute value. Okay?